All right. So today will be the second section for your lecture 6 and also generics, the first part. Let's see if you got any more questions. I don't see any new questions on the Google Doc, but as usual, let me go over some announcement and then open the floor. I think I also got my agenda. I'm going to go over the written question together with you about the example question for written test 3, just to give you maybe a little bit more tips before you attempt the test. Let's do that, okay? Before that, let me first of all just to go over with everybody about the semester calendar. We got 2 more weeks officially for the course, of course, in addition to the exam. By the way, in the for the exam, I sent out an announcement last night, just about if you're interested in attending some like a Zoom review session, more like a Q&A. You know, pretty much like what we have been doing since the beginning of the semester. I suggested certain times in the e-class. If you're interested, go there and then specify all the times that work for you. And then maybe sometime early next week, I'll fix the dates. I'll try to fix either 1 or 2 days to actually answer your questions before your exam. Okay. Anyway, so if you go over the semester calendar, right? So today we are now the 25th of November. Of course, you're going to have your written test number 3 either today or tomorrow before 2 p.m. Don't forget, before 2 p.m. tomorrow. And your lab number 5 was released in time since Monday. So you have to make sure that you actually follow the deadline, right? Deadline will be December 6th, also 2 p.m., right? So far, the deadline has been like a Monday, 2 p.m. You have to, it will be difficult to push this deadline a little bit any further, because we have to make sure we do the grading and also maybe give you some chance for regrading if needed before your exam. So I also need to coordinate the TAs for that. So it's really hard to push the deadline any further. Please make sure you plan your time for that lab. If you got any trouble, I still got my office hours, right? In the coming 2 weeks. And your lecture number 11, which is pretty short. I'll speak about it a little bit. You know, there's a reason why it's actually short. But for your week number 12, that will be the last lecture for this course. And we're going to talk about a topic called recursion. You may have been exposed maybe to this subject, maybe not in 1022, I don't think so, or 1021, but maybe briefly in 1012 or maybe 1015. That's my guess. But if no, that's okay. I'm going to show you from scratch. It would be a very good like a connection point to the next course, to this one, which is EECS2030, the data structure course, which maybe many of you will take that next semester. You definitely have to have the knowledge about recursion in 2011. So it's good to actually give you some foundation at the end of this course. Okay, and then your programming test number 3 is going to occur next Thursday and Friday. And the time will be as usual, 24 hours period, and for 90 minutes. I posted some simple, I gotta emphasize this is simple example test based on your lecture example, the resident students example. But that one should be good for you to get familiar with the format as usual. And I'm going to record a solution walkthrough for your lab number 4 solution. I'll try to make it available by the end of the coming Monday, the 29th. So you got at least another 2 days to go over the solution. And hopefully you can also consider redoing your lab number 4. So that's the best preparation strategy, I think. All right. And then let's see what else. And after that, okay. So your exam has been scheduled by the registrar office. You can definitely check it. It's official. Everybody has to follow that, including myself. And then if you got any trouble understanding any materials, since the beginning of this term, including week 1 and week 2, the review of OOP, they will all be covered in the exam. It's going to be comprehensive. So I will really suggest you actually start preparing for your exam, maybe gradually. I think you still got a good amount of time, like 2 weeks before the actual exam. So take advantage of that rather than, just a few days before the exam to cram the information. It's not so good beyond this course. Okay, so let me see if I missed any announcement here. Oh, actually for week number 11, right? So there's only 1 hour for the video that you gotta watch for a reason. Let me explain that quickly so you wouldn't get confused. So the 1 hour is really to finish off the generics in Java. Okay, especially how you can actually declare generic classes in Java. You have to make sure it's very clear to you how you can compare and contrast generic classes versus general classes, like an object array. And beyond the 1 hour, I'm expecting you really should try the exercise as follows, right? So one is about the programming exercise, which you can find at the end of the slide for the Java generics. And that one is really for you to program the general book versus generic book. Versus generic book. So that is something I would expect you to complete. Maybe it's not going to be covered in the coming written test, but it will be covered in the exam. So if you got any trouble completing them, you should really speak to me, right? But of course, in the review session, you can also ask me. I can maybe talk about it briefly, but you should really do it first. Another item there, which I will also expect you to really do, if necessary, is about to review the details about array list and also hash table. I think in the case of 1022, in the past winter, I think you learned about the hash table and array list. In that case, you can just review your notes or maybe your lecture recording briefly. In case you actually came from either 1720 for digital media or maybe 1021 from engineering, feel free to actually catch up with this material if you haven't learned it before, but it will be assumed for the exam. So that's why I'm allocating some extra time in the lecture actually for you to actually catch up, right? If you got any trouble understanding these two, if you didn't learn it in the first year, you should really reach out to me, right? Okay, so that's about the week number 11 lecture. And then lab number 5, as I spoke about it, written test number 3. What I will do is I'm going to go over the written test, like an example test question I made available to you, just to maybe mention some tips, like how you should really solve this kind of question, right? And for your programming test 3, and again, for your lab number 4 solution walkthrough, like a video, I'll make it available by Monday, okay? By the end of Monday, I'll try my best. So Monday, November 29th, I'll make it available to you, all right? Good. Do you guys have any administrative questions for me?
Hi, sir.
Yes.
I have a question.
Yes, go ahead.
I just saw the learning outcome for the course, and it's talking about implementing linked list and some other things.
Yeah.
Would that be part of the recursion?
Not really. I think it will definitely cover recursion. Yeah, yeah. So the question was, when you look at the learning outcomes for the course, you actually saw something about linked list. Actually, we already stopped covering the linked list in this course already. Given the advice from our vice chair for the program, because we're going to cover that substantially in 2011. So for the linked list, you don't have to worry. We're going to cover that in the follow-up course to this. And you also see that 2 more topics. One is about how to derive the running time for recursion, and the other one is about how to prove the correctness for recursion. This is also something we'll cover in 2011. Okay, so you don't need to worry. So, but about one thing that we're still missing is about the how to implement recursion. So that'll be the focus for the final week. Right.
Thanks, sir.
No problem. All right. But as far as the exam is concerned, basically you can safely assume all the lecture materials will form the basis for your exam. Anything that we really didn't touch upon in the course, they will not be covered. That you can safely assume that, right? Okay, any other administrative, John?
Yep, sorry. So in terms of week 12's lectures, because the week after, like our sessions on Thursday would be after, like it would be technically in the exam period.
Right.
Would that be still held or no?
Yeah. Okay, I see your question. It's a valid question. John's question was, so if you look at the timeline, so I will release week number 12 lecture, but if you look at the schedule here, so on this week, I cannot hold anything on the 8th because it's more like a study day. So university wouldn't allow me to do that. John, you know what? Let me think about it. I'm thinking that maybe what I would do, in addition to the review session about the exam, what I can do is I can maybe schedule just one session, which will combine section B and section E. And then that one maybe can be dedicated to answering questions related to week number 12. So in case you got any question, let me get back to the class on this. I'll keep that in mind.
Okay, perfect. Also,
Okay.
in terms of ArrayList and hash tables, there's there like I know in 1022 you had like, a couple of videos towards the end of the course were like related to that. Are we supposed to watch that to get like a brief?
Yeah, so okay, depends. If you already know about array list and hash table, I would suggest take a look at the example code I included in your lecture number 7, the generics in Java course class. If you're okay with all the basic method call for array list and hash table, you don't really need to watch the 1022 lecture. On the other hand, if you are really new to using Java collection library, then I would suggest you actually watch those recording, which take less than 1 hour to actually study.
But those are the ones, right? If we don't know, those were like the last couple of videos. Those are the ones we watched, right? Because I couldn't find anything but those. Just checking.
You're saying like a way? Sorry, can you say that again? You mean like a where to find the materials for array list and hash table? Yeah. So I think watching those 2 videos should be enough. Just about the basics for hash table array list. Yeah, that will be it. I think okay, just to be more precise. So those 2 videos came from here. Give me a moment. If you go to 1022, as you pointed out, if you go to the final week, I think the 2 videos I suggested to you was this one here, just about tracing the code for array list, and also this one here, tracing the code for hash table. I think these 2 should be sufficient. But if you really want to maybe get some background about how to read the API for Java, you may also want to look at part A as well. I'm not too sure if your previous instructor actually covered that. If they haven't, actually they should. Anyway, so you can take a look and then to get some background. But if you got any doubts, you can always just come to me. I can tell you if you miss anything. So John, does that make sense to you?
Yes.
Okay,
thank you.
Awesome. Very good. Yeah. Okay. Okay. Seeing no further administrative question. Okay. I would suggest this. I have your written test 3 example question over here. Okay. I'm ready to go over that with you. But before that, do you guys have any general questions just about the lecture, inheritance, polymorphism, dynamic binding? Do you have any question before I go over the question? Of course, you can still ask me after I go over the question, but just before that, I can give you priority. Anybody?
I have a question.
Go ahead.
So this is about you know that required reading that you gave us?
Okay.
Yeah.
Oh, you
So
mean
at
something
the
about the typecast?
Yeah, it's
Okay, yeah,
it's
give me a moment. Yeah, give me a moment. Yeah, I can point it out in case people are not too sure what you're talking about. Give me a moment. Actually, sorry, that's 1022. Yeah. Okay, let me go to 2030. I believe that one should be in week number 8. You're talking about this reading here, right?
Yeah.
Okay, okay, sure. What about it?
So at the very bottom,
Sure.
like the last thing.
Sure.
I just that sentence at the end about the class cast exception got me a little bit confused.
Okay, sure.
Like,
yeah, no problem. I can go over that quickly. At the runtime, there is a class cast exception when the dynamic type cannot meet the expectation of the reference variable determined by. Okay, I think you know what? I'm glad you pointed it out. This could be some legacy sentence from my previous note. Let me fix this one today after the session, and then. But for now, let me clarify that. Would that be okay? Let me do that.
yeah,
Okay.
of course. It just didn't make sense to me. That's why.
That's okay. It didn't quite make sense to me either, to be honest. But I'll fix that. Okay. Let's now talk about it. Okay. Basically, let me just summarize. Basically, in a short way, like what you're supposed to check. Okay. Let's say whenever you want to do a cast. Let me make it a little more symbolic example. Okay. Let me say this. Okay. Let's say you have some variables, let's say of type C1. Okay. Let's say C1, you have some variable, and then it's assigned to new, and then C2. Okay. So here, C1 and C2 are simply some classes in Java, and C1 and C2 may be the same, like students and students. but they may be different. For example, students and resident student, right? So that's why I'm making C1 and C2, but they can be different, they can be the same, okay? And very quickly, when will this particular substitution be valid? To save everybody's time, so we know that it should be that C2 satisfies the expectation of C1. That should be very natural to you. And also, formally speaking, C2 is a descending class of C1. So that'll be the validity rule that we talk about, like rules of substitution. And one thing to mention, of course, alternatively, so this one here is equivalent to saying C1 is an ancestor of C2, right? They're equivalent. Okay, I wouldn't write it down, but you know what I mean. Okay, so that's about the variable assignments. Let's now talk about casting. So what's really happening here, let's visualize this a little bit. It's rather easy. So let's say V is now really pointing to this particular object over here, and we use the title of the box for the object to denote what the dynamic type is. So this will be C2, okay? So basically C2 over here is the dynamic type of V. And sometimes it might be useful for you to also annotate about what the static type is for the variable. In this case, C1 is the static type, right? Static type of V, right? So I can also put C1 over here, right? That's how you visualize it for single objects. Let's now talk about casting and then talk about how class cast exception might occur, okay? Let's now talk about this. So let's say if we got let's talk about anonymous cast, okay? If you actually got, let's say, another class called C3 over here, I'll give you some concrete example in a moment. So if you look at C3 over here and then you say V, okay? Like that. So this is a cast. Okay, so this is actually a cast. And we are actually trying to cast V into another type called C3. Okay, and whenever you talk about typecast, let's try to recall the story that was told in your lecture. So there are two aspects you have to watch out for. One is about compilation, and the other one is about at the runtime whether or not the class cast exception will occur. So these are the two aspects. Let's review them one by one. So number one, does the cast compile? Does the cast compile? Right, you should know very well the way to judge it is to make sure it's either an upward casting or downward casting, right? It's either an upward casting, up or downward. Okay, so that means C3 over here should be either an ancestor or descendants of the static type of the variable that we are trying to cast. So in this case, the static type, so here the static type for V is actually C1. All right, are you okay so far?
Yeah, that's good.
Okay, yeah, it's a little bit symbolic, I know, but it's a good way to summarize what we have learned. I'll point to you the concrete example you should really watch out for. Okay, that's good. Now let's go to your question about the nodes. Okay, so now the second aspect you really want to do. Oh, by the way, so here I'm saying that it will be valid cast if C3 over here is either an ancestor or descendants of the static type for the reference variable. So consequently, this wouldn't compile. This would not be valid if C3 is neither ancestor nor descendants of the static type C1. And I'm going to point to you an important diagram back in the lecture notes. So that one kind of summarize all the four categories, right? About the smartphone example. I'll point you to that. It's actually quite important to also review that. Okay, number two. Okay, that's about class cast exception. So here's the principle, and I'll try to rephrase what I said in the notes. Class cast exception. Okay, actually, what it's really important to know, given that it compiles. If the cast doesn't even compile, you cannot even run it. So there's no way to actually know whether there should be some exception, right? That's very important to know. Given that the cast compiles, there will be a class cast exception. Yeah, there's also something I've emphasized actually many times in the lecture video. You may want to rewatch those parts if necessary. There will be a class cast exception if the dynamic type of V, right? You can see we are trying to cast V into something, into C3. And we're talking about runtime, whether or not there will be a class cast exception. So that's why at the runtime, if you want to analyze about runtime behavior, you have to involve the dynamic type, right? So V over here, we know that dynamic type is, at this point, C2. Okay. If the dynamic type of V, which is C2, cannot fulfill the cast type. And in this case, we are casting V into C3, right? So that's C3. All right, let me say a little bit more. In the lecture, I remember I tried to phrase the same criteria in 3 different ways for you. So this is one way to say there will be a class cast exception if the dynamic type of the variable V over here, which is C2, cannot fulfill the cast type, in this case, which is C3. That's one way to say it. Let me say it the other way. Or you can say it if the dynamic type V is actually not a descendant of the cast type, right? If it is not a descendant of that, in that case, you cannot fulfill its expectation. Another way to put it would be if it is the case that the cast type is not an ancestor of the dynamic type. So these 3 are all equivalents, right? You can look up your iPad notes for that particular lecture. I actually spoke about all the 3. You can look for them. All right, so that's about what I want to summarize. Does it help? Did it clarify?
Yeah, I have a question about that though. So
yeah, which part?
So you know how we can upward or downward cast, right?
Yeah, yeah.
So if you upward cast, that means the expectations go down on what you can use, right? So why is it? I'm just trying to relate like that idea towards when you cast a dynamic type. So
yeah.
Maybe you understand what I mean already.
Okay, so let me make sure I really understood. So you're asking what would be the value or what would be the usefulness of doing the upward casting? Is that correct?
Well, no, it's more like wouldn't technically a class cast exception, like the way you explained it right now, like so if C3 wasn't an answer
I see what you mean.
class,
Now I see what you mean. Let's take a look. Let's make a slightly more concrete example, but I'll still make it symbolic. Let's say A. Let's say B here. And also C here. Okay. Let's say we got some method over here. Let's say we got method M1 over here, method M2, and also method M3. Okay, let's say there's no overridden methods. It's just that in A we newly declare M1, in B we newly declare M2, and in C we newly declare M3. Let's say, okay, you can always declare as many new methods as you like in the subclasses. So let's now talk about this. Okay, let's now say, let's say B, let's say objects is assigned to new and then B. In this case, the static type and the dynamic type happen to be the same. So you can see this part here is the static type. And this part over here is the dynamic type. They just happen to be the same. Okay. Let's now talk about upward casting and downward casting to see why upward casting will be okay, whereas the downward casting will not be okay. Okay. That's exactly what you were asking. Let's talk about downward casting first. Okay. So for downward casting, so let's say downward cast, right? So let's say for objects, let's say if you're trying to cast that, you can see the static type is actually B. If I try to downward cast to C, okay, like that, okay. So why would this run into class cast exception? It is because if this was allowed, okay, if this was valid, and you should really review the way we try to do some proof by contradiction, right? So now I want to somehow prove that this cast over here should not be valid, right? And the way to prove it is by assuming that what if this is valid? Like, how can this lead to a crash? So that means our original assumption that it was valid was actually not, should be the opposite. So that means it should be invalid. Okay, let's see why. If this was valid, so that means we can invoke what's expected on C, class C over here, which is a cast type, on the cast objects. By the way, at the moment, you should really visualize what's happening here. At the moment, you can see OBJ is actually pointing to some object over here, which is dynamically is actually B. And remember, what will be the expectation for B? Only M1 and M2, right? Let me write it down here. It's not really attribute, but just for informally, I can put M1 and M2 here. And statically, this reference over here is actually B, right? Never changes. And for this particular cast over here, if we allow it, okay, so that's going to be C and then OBJ. It's more like an alias that's also pointing to this object over here. And if we actually allow this, so that means we should be able to invoke certain methods that can be expected on C, for example, N3, right? So for example, I can try to do C and then OBJ. So that's a cast exception, the cast expression. And then I'm trying to invoke N3 over here. So if we try to do this, what's going to happen? If you say this cast over here dot N3, do we have N3 on this dynamic type B? We don't, because N3 is only exists in the descendant class of the dynamic type. So that's why it cannot be allowed. Are you okay so far?
Yeah.
Good. Okay. And then I'll go back to your upward casting. Similar story, similar reasoning pattern. So this will be a crash. Okay. So that means it should be invalid. Okay. At the runtime. Okay. So that's about downward casting. What about upward casting? So when we try to do upward casting here, so if you do upward casting, let's say we got OBJ, and the static type is actually B over here. Why don't we upward cast to A? This should be valid because this, if this was valid, what can you invoke on this cast expression? Anything that's expected on A, which will be just M1. So that means you can do something like this was cast to A, and then, right, parenthesis, and then dot M1. M1 is the only expectation of class A. In this case, can you invoke M1 on this object here dynamically? Indeed, because B is a descendant of A. So that's why we said over here, it will be a class cast exception if the dynamic type cannot fulfill the cast type. In this case, can the dynamic type B fulfill A? Indeed, it can, because it is a descendant class of that. But can B fulfill C? In this case, it cannot. So that's why we get a class cast exception.
All right. Yeah. Thank you. I was a bit mixed up about something, but
That's okay. You know, I think I tell you what. You know, if this is your first time learning this, most likely yes. The story is actually quite sophisticated. It takes some time. You just need repetitions over and over to get it through.
Sounds good.
Okay, good. All right. John, do you have any follow-up or other question?
Yeah, it's a question similar to this, but it's more to like function calls. comparing, like, so if a function call is part of the expectation, then it compiles, and then we can look at dynamic binding. But if it's not part of the if it's not part of the expectations of one of the ancestor classes, then we don't look at anything, right? Because it doesn't compile.
That's correct. That's correct. Let me also illustrate that quickly for everybody. Sorry, let me just put the clock so I can watch out the time. Okay, good. Let me do the following. Okay, let me try to elaborate John's point a little bit more. Okay, he basically said two things. Number one, let's still use this upward casting example, right? Let's say I'm trying to do some upward casting. So I got A is cast to A, OBJ. And it's really important for you to know this cast over here has the static type, this expression here. So this expression with the static type, as we said in the lecture, matching the cast type, A. So that means whatever method you want to call using the dot notation can only be those that can be expected on class A, which correspond to A, right? So M1 is the only one. But if you say M2, if you say M3, they should all be invalid. Not good and not good over here. Let me use red. Not good and not good. You can see for M2, even though the dynamic type is actually B, which will support M2, but still it will not compile because remember, compilation-wise, we only look at the static type. In this case, the static type for this cast expression over here is just A, corresponding to the cast type. So that's the first thing that John mentioned. The second thing, which is about dynamic binding. Let me add a little bit more details to this diagram over here. Okay, let's say in this subclass over here, we also decided that we want to redefine, or we want to overwrite the inherited method here. So that means M1 over here is going to be overridden. Okay, let's say we do that. Okay, and this overridden version of M1 is also going to be inherited to C, right? If you go to the last part of your inheritance lecture, when we talk about equals method, right? You'll always go for, if the method is not the overridden in the current class, you need to find the closest overridden version in the ancestor, right? That's something you can refer to in your inheritance lecture, the last bit. Okay, let me just give one example to say about dynamic binding. Okay, let's say this. Okay, so number 2. Okay, so that's about dynamic binding. Whenever you want to analyze about runtime behavior, like which version of the method that should be invoked, you should really look at dynamic type, right? That's also summarized in your slides. So now in this case, let's try the same cast, obj, and then dot and 1. Okay, this one will illustrate exactly what John was asking here. Okay, first of all, you can take a look at this cast expression over here. As we said, this expression here has the static type A. So this is why you can actually expect M1 on that. M1 is actually declared an A. Okay, that's about the expectation. But now the question is, which version of M1 will be invoked? That's a critical question, because you can see we actually got more than one versions for M1. This is the original version, and this is the overridden version. And now which version will be called? It depends on what the dynamic type is for this expression over here. And as we said before, the typecast does not create any objects. They only try to create an alias to some objects with a different static type. In this case, we are just creating an alias like this. Okay, yeah. So let me just write it down. So in this case, we're just creating an alias over here to the same objects. It's simply cast to A. Okay, over here. And dynamic type remains to be B. So now we're going to invoke the version of M1 in B if it is overridden. Indeed, it is. So that's why we're going to invoke this version here of M1. Okay. Okay, which is dynamic type for OBJ. So John, makes sense to you?
Yep. So as long as the function, as long as like M1 is part of static type like A, then we go to the dynamic type and like can go
That's
like
correct.
upwards
That's correct.
until we find the
Yeah,
okay.
static type is for you to judge whether or not you will compile, whether the method can be invoked, as part of the dot notation. And if you want to analyze about what exactly will be called at the runtime, especially if you got more than one version, like one original version, maybe several overrated version. If you want to know which version will be called, you need to look at the dynamic type specifically. Make sense, John?
Yes, thank you.
Okay, awesome. Good. Guys, everything we have spoken about so far are very important. Everything. Okay, I'm glad you guys asked me a good question. All right. Okay, any follow-up before I go over the written test question? Anybody? All right, let's now go over. I'm glad you guys asked me because this is something I wanted to mention anyway. Because in your example questions, as you can see, we didn't say too much about the typecast story. Maybe for the final one, if you look, I'll talk about it. The final one actually require a little bit of like a typecasting, if you want to call the method, which is like what John just mentioned. But I'm glad I actually spoke about quite many review about how you can analyze about the typecast and whether or not you will compile, and also whether or not you will run into class cast exception. Let me just refer to you one more diagram, and then we'll go over the written test question. Okay. Let me point to you where you should really look at. If you go under, let me remind myself, if you go under week number 8, I think that will be it. And then go to the notes. Okay. I think I pointed this diagram to you guys when we actually held the Q&A session earlier, but I want to repeat. Towards the end. Okay, almost there. This one here, right? This diagram here quite nicely tells you about, given any hierarchy of classes, this one's reasonably complicated, right? So given the static type, and also given the dynamic type over here, how can we divide the classes into 4 categories, right? Either the category where the typecast will compile, or the category where the typecast wouldn't compile. For those that compile, you can subdivide them into 2 categories. Either those that will run into class cast exception, or those that wouldn't run into class cast exception. So you can try to study this together with the review I did just about 10 minutes ago, right? That's something, this is like a more concrete example you're familiar with, okay? I think the way I try to cover typecasting inheritance very thorough, I think it will definitely lead you a long way beyond this course. So don't abandon the story you have heard and understood in this course. Not just for 2011, I think later on, once you get into the 3rd year, when you learn about maybe software design, like a 3311, most likely you have to have some very complicated inheritance hierarchy structure. In that case, knowing how things may be cast and knowing that how dynamic binding, polymorphism work will definitely be very beneficial to you. Okay, let's now go over the written test question, which I wouldn't think that will take too long, but let's see. By the way, I also sent out an E-class announcement earlier this morning, just give you a little bit more tips, right? You can read over the tips, but one of them was you want to have a piece of paper, physical paper, right? Well, of course, if you like me, you also got some iPad to write down your notes. That's fine too, but you need some stuff, some item for you to sketch your ideas, right? Especially for diagram, okay? And you can take my word for that. Also for the exam, you definitely want to have sketch paper ready when you actually answer the exam. I'll give you more tips later, okay? So given this type of question, I would suggest you actually try to convert the Java class declarations into the hierarchical diagram. Okay, let's try to do that together. And all the questions related to this diagram can just be answered quite easily. Maybe I shouldn't say easy, maybe quite straightforwardly, from the question. Let's see. So I will just go class by class, right? So first of all, I see I got 2 classes here. A extends B, right? So what I will do is I will have A over here. A extends B. You know what? Let me just. I know it's going to be quite a few classes. Let me save the space. Okay. Let's say A here. A extends B. All right. By the way, whenever you say extends, right, you got to be careful with the direction of the arrow. It should be this way over here, which will go from subclass to superclass. And also you got B extends C. B extends C. And C will just stand alone, right? However, C itself actually declares a method BM, right? I'm going to write BM over here. And then that one there is going to output C dot BM, right? I'm just doing some annotation. You might have a different style, but at least that works for me. And then the next class will be D. D extends C. And then for D, we actually got a new method CM, right? So that's going to be a new method CM, which will print out D.cm. All right, the next one we got F. F extends D. And over here, we actually got BM, which is overridden, right? We got BM over here. That one is going to print out F.bm. And also we got another method here, EM, which will print out F.em. All right, finally, we got a class called E over here. E will extend F. Like that, okay? And then E will actually got DM. And then it will print out E.dm. Okay? Of course, if you got highlighter, you can feel free to do some annotation. But for example, I would like to do the following. BM is the method that will get overridden. You can see BM over here. It was overridden in this class over here, right? You can see that we got two versions of BM. That's really something to note. So that's about converting the Java classes into a hierarchical diagram, right? Hopefully that's straightforward to you. You just need some practice. And if I were you, I will try to maybe say I got 1, 2, 3, 4, 5, 6 classes here. Why don't you try think to yourself, what if I got another class over here? I got another class over here, maybe another class over here. How should I modify the class decorations accordingly, and how should I modify my diagram accordingly? Right? That will be some extra exercise you can do on your own. Okay, I'll leave that to you. I just want to give you the idea. And now let's answer the questions quickly. Okay, for the detailed response, the detailed written answer I already included as a feedback on the e-class. You can definitely look at them, right? I'm just gonna go over them one by one. So here, if I got this substitution, should that be valid, right? You want to check to see whether C is a descendant class of D, right? So now let's look at the diagram. Is C a descendant class of D? No, it is not. It's the opposite. D is actually a descendant class of C, so that's why it wouldn't compile. Okay. Okay, hopefully the first one is fine. Okay, how about second one? So now we got similar assignments here. So now is D a descendant class of C? Is D a descendant class of C? Indeed, it is. So that's why this will compile. Okay, let's now continue. Of course, the one we are doing here, it's a little bit not like on Eclipse. Of course, on Eclipse, if you got this line here already not compiling, you cannot really continue with the execution. But for this question here, we only execute those lines that actually compile. So you can actually answer the later question. So now in this case, let me just visualize it over here. So you actually got D2 actually pointing to some objects over here. Dynamically, it's actually D. Okay, for D2, statically, it's C. Okay, I'm just visualizing it. Let's now take a look at the next line. What about D2, the BN? Whether or not this will compile depends on the static type for D2, right? If you look at D2, D2 statically is C. Does C have BN? C does have BN. So that's going to compile, all right? So that's why this will be compiling. And more to it, dynamically, which version of BM are we going to call, right? Now you can see we got one version here, like what John suggested before. So now in this case, since we know D2 dynamically is pointing to D, so that means it's going to call the version that's in D. So that's why that's going to print out D.cm. Oh, sorry, let me say it again. Beg your pardon. We're going to call the version of BM on the dynamic type, which is D. You can see D here itself does not overwrite BM. So that means it's going to find out the BM in the closest ancestor, which is C. Okay. So that means this one over here is going to call the version of BM in closest ancestor. In this case, it would be C.BM. All right, so that's this line here. Okay. All right, let's now go for the next line. What about this line over here? Okay. Okay, so it will be a similar exercise. Now, is E a descendant class of D? Is E a descendant class of D? It is, right? So that one should check. All right. So that means after this line, let's visualize it. It's going to be E1 is pointing to some objects dynamically that's E, right? Of type E. And static type for E1 is actually D. Okay, let me put D here. All right, so now let's take a look at the next one. We want to do D2 is assigned to E1, right? So the rule of substitution tells us you should look at a static type for E1. What is the static type for E1? D. What is the static type for D2? It is C. In order to do this assignment here, you want to make sure the static type for E1, which is D, is actually a descendant class of the static type for D2, which is C. Is D a descendant class of C? Is D a descendant class of C? It is, right? So at least it will check, right? It will compile. And then after this, what the consequence would be, D2, rather than pointing to here, right? D2 is going to be reassigned to E1. It's now going to point to this object over here, right? And one thing to note, right? After this, I think that's also part of the question. After this, static type of D2 should remain the same, right? It's always C, always. But the dynamic type of D2, since it's now pointing to this object here, it should be E. Remember, static type never changes, but dynamic type can change as often as you like. Okay. Let's now talk about this line here. When we say D2.BM, right? So D2 is now pointing to this object over here. Dynamically, it's E, right? Would this compile? Statically, D2 is actually C. Does C contain the method BM? It does. Okay, so it will compile. But what about which version that's going to be called? In this case, D2.BM, what's the dynamic type? Dynamic type is actually E. So E is over here. Does E itself got BM? No, it doesn't. So we need to look for the closest ancestor, which will be this method over here, right? BM. That's the closest overridden version. Okay, so this one is going to be version of BM in closest ancestor, which will be F. Yeah, over here. But of course, the BM is actually also going to be inherited to E. So you should really say the version of E, which is inherited from F. Okay. Oops, sorry. All right, I hope so far it's clear. All right, we got two more lines quickly. Okay, let's say the next line. What about this? This one here. We have E1. Okay, E1. We know that E1 statically is D over here, and then we want to assign to something as F. Is D a descendant of F? Is D a descendant of F? No, it is not. So that's why it's not going to compile. All right. So let's now try to invoke this method over here. Let's say E1.em. Okay. E1 over here statically is actually D. Does D support EM as part of its expectation? So if you look at D over here, it does not have an EM because EM is actually here, right? So it will not compile. So for this line number 8, okay, let me say that specifically. line number 8. Okay, E1 dot EM. Okay, let me say that in a little bit more detail. So first of all, we know E1 statically is D. Static type is actually D. But EM over here was only declared in the descendants of D, which is F, right? Not expected on the static type D. So that's why it's not going to compile, right? That's the part 1. But now, how can we make it compile and also work, hopefully? The way to do it is you can use a cast. So what we can do a cast like this. We know that dynamically, E1 is pointing to some E objects over here, right? It's pointing to that. And E will definitely support EM, which is inherited from here. So you got 2 choices. I actually got asked this question in the office hour yesterday. So now you can see static type is actually D over here, and we want to be able to call EM. You can either downcast to over here, which is still an ancestor for the dynamic type, so we wouldn't run into class cast exception, or you can downcast to just that class, which correspond to the dynamic type, which is E. So you got 2 ways. I'll write down both. Either you can say E1, you can cast that into F. Okay, and after that, you will be able to call EM. Or you can try to say E1, you'll cast that into E over here. And we can also invoke EM. So these 2 are both acceptable answer, both of them. Okay, and the question is, are they both going to call the same version of EM? The answer is yes, because both of them are simply just different aliases to the same object over here. As we said, the typecasts do not really create any new objects. They only create new aliases for the same objects. Okay? In that case, when you try to invoke EM, right, it's going to invoke the version that's actually in the dynamic type E. And in the case of dynamic type E, it's going to be inherited from F, right? So that's the version. Okay. Let me write down the last point and then I'll take your question. Okay. So this part over here, EM and also EM. So both of them are going to be the version from E, which is inherited from its ancestor, F. All right. That for many things, I simply just describe them verbally, but that one really corresponds to what I wrote as a feedback for your example question. Hopefully, you can look at both together. All right. So, MD, makes sense to you about the whole walkthrough? Okay, maybe you're okay. Adnan, go ahead.
Hi, sir. You have to do typecasting, right? If E1 and E1, right?
Yep. So here, if you only say E1.em, in this case, you wouldn't compile because EM is not supported by the static type of E1. So that's why you have to downcast. Yeah. You can, in this case, you can either, this is the dynamic type, this is the dynamic type E over here, right? And this is the static type. So you can either downcast to over here, or you can downcast to here. Either way will be okay.
Yes, sir. I just wanted to know when you cast that, right? You said that it creates an alias. So
correct.
That alias would always be to E1 in this case, right? So for example, if E1, the cast type, would point to wherever
exactly
E1 is pointing to dynamic.
Yeah, exactly.
Right?
Let me
always the case.
Exactly. Let me write it down. So what's going to happen is, let's say this one here, as you mentioned. So this is going to be E1 that's cast to type F. Okay. So this expression over here is indeed an alias to the same object as E1, right? Remember, this is E1. The only difference is this link over here has the static type D. This link over here has the static type F from the compiler's point of view. But they both point to the same objects. So that's why later on, when you try to do this cast or this cast.em, it will actually invoke the same version because dynamically it still boils down into the same objects.
Okay, and there's kind of no exception to that, right? So whatever.
In this case, in this case, there's no exception. No.
Oh, what about the general case? It will always point to the new alias that we create when we do casting, right? It always points to the dynamic type of whatever.
Exactly. You will always point to the objects that's over here, and the object itself has the dynamic type. Yes.
Sure. Thank you, sir.
Yeah, no problem. Let me say one thing I can say. Okay. Let me see here. Let me copy that. Okay. And then I'll take other question. Give me a moment. A, B, and C, and then D, F, E. Okay, and then we got BM, CM, EM. I want to do one more example for you, and then BM, EM. And then we got DM. Okay. Okay, and then let's say this. Okay, and then we want to do E1 dot EM. Okay. That's what, and we said earlier that this is not going to compile, but we need a cast. Let's say we introduce one more class to the diagram. Okay, can I say I introduce this diagram here? Okay, let's say G. Hypothetically, okay. Let's say now I want to do the following. Okay, let's say I want to cast E1. By the way, so E1 at the moment is pointing to dynamically some objects of type E, right? Don't forget about the visualization. Okay, E over here. Okay, and statically it's D. Okay. Let's say we introduce this new class over here, is like a subclass of E. What happens if I try to do this? E1 over here. Oh, sorry, let me write it down properly. E1 over here, I want to cast that into G. And then after that, I will try to invoke dot EM. So this could be an extra question for you guys. Why don't you think about it? I have two questions for you. Okay. Question number one, does it compile? Question number two, are we going to run into any exception? So this will be some extra exercise for you. You guys can feel free to try. Maybe put on the chat, or if you want to speak up about this exercise over here.
It certainly compiles because it's.
Okay, that's good. Okay, good. I like the confidence. Yeah. So here, yeah, that's downward casting. Good. Okay. Let me. Okay, very good. The first part, it seems to be quite easy. Let me just talk about first part. Right. This part here, we know that. Just some repetition here. Static type should be matching the cast type, which is G. And the compiler simply asks whether or not EM can be expected on G. Indeed, because EM will be inherited all the way to G, the descending class. So number one is okay. All right. What about number two? Are we going to run into, since the code compiles, so we can run it, are we going to run into any kind of exception?
For sure, I think so, because E1's dynamic type, right? It doesn't, it's an ancestor of G, so it's not
okay. Good. Very good. Because over here, dynamic type is actually E. And you're casting that into G. Can E satisfy the expectation of G in general? No, it cannot, right? An ancestor can never satisfy, well, it's assumed by the compiler that it cannot satisfy the expectation for its descendants, right? Yes. Class cast exception, right? Because dynamic type of E1, which is E, is not descendants of cast type, which is E, right? You can see E is not a descendant of G. It should be the opposite, right? So this is an extra one for you, all right? Okay. Okay, so question from Hasmaram.
Hi.
Hi.
My question was, can you give me an example of using these classes, but like getting the information from its sibling, like from the other side, from class A or B?
Sorry, can you repeat the question again? You're asking, are you asking about how we can, if we can cast from sibling to another?
Yeah, like from class either E or F to B.
Yeah, it's possible. That's also addressed in one of the exercise. I'll point out to you. Okay, let me just talk about something simple here.
Yeah.
Let's say this. Again, let me use ABC, right? A here, B here, and also C here. Okay. Let's say if we have, let me see. Okay, let's say this. If you say B objects new B. Right, for simplicity, I simply got static type and dynamic type being the same. All right. Let's now try. Okay, let me just give you several intermediate points. So let's say this. Let me say I got, let's say, AM, BM, and also CM. Right, we got three methods here. Okay. So now, if I say this, if I say obj dot cm, right? If I try that, well, it should be quite obvious to every one of you it's not going to compile because the static type of obj is actually B, and B cannot be expected on cm, right? So it's not going to compile. Now the question is it possible to really cast obj statically is B somehow to its sibling? It is possible, even though you'll run into some trouble at the runtime. But let me review this point, and then I think there's one exercise in your inheritance lecture that's also talk about this, right? So the idea would be you can simply look at the diagram. Is there a path to go from B to C? Yes, you can always go up and then go down. You can do two cast, okay? You can do upward cast followed by downward cast. So what we can do is like this. You can do, let's say, obj. First of all, let's do an upward cast to A. And then, after that, you can do a downward cast to C. And then, after that, this particular expression over here is going to be, I'll just say this, and then I'll try to annotate a little bit further. And in this case, we can say CM. Okay. So this will actually compile, funny enough. Okay. The reason that it will compile is like this. You can look at just this part over here. This part over here is basically casting from B to A. So this is upward casting. So you're going from B to A. And the cast expression has static type matching the cast type, which is over here. Okay, over here. All right, so that's this part here. And then now, can we actually cast from A down to C? Indeed, it's a downward casting. All right. So that's why it's really important for you to see this as A. And then this part over here, I'm going to say this part here, right? This part, just this part. So this part here is actually downward cast. And we're doing from A down to C over here. And then the cast expression static type is actually matching the cast type, which is C. And now you know that the static type is actually C for this expression here. Is CM defined in C? It is. So that's why it will compile. All right, so that's what you asked, right? Just about whether you can cast from one sibling to another. Good, it will compile. But you're gonna run into trouble at the runtime because it boils down, into think about the whenever you do casting, you're just fooling around the compiler. Yeah, so whatever you if you do something that really doesn't make sense, eventually you gotta pay the price at the runtime. So that's kind of the purpose for that exercise over there. Because in theory, in Java, you can always think about this, right? In Java, let's say we got A here and B here. Let's say A has nothing to do with B. They are not related to by inheritance hierarchy whatsoever. But it's still possible to fool around the compiler to let them allow you to cast from A to B. And the way to do it is remember there's an object class. That's the implicit parent class for everybody, right? So you can always upcasting to objects and then downward casting to B. It's always possible, right? Compiler wouldn't check this for you, so you got to take the responsibility whenever you do such upward and then downward casting. You really need to know what you're doing. So now in this case, if you try to fool around the compiler, so they allow you to compile this code, but if you execute it, what's going to happen is, let's say this. In this case, let's say obj. I'm just trying to visualize this line here, right? This line here, original line. You can see obj is pointing to some object dynamically that's B, right? So now you're trying to cast basically dynamicize B. Eventually you want to cast that into C. You're going to get into trouble. Can B fulfill the expectation of C? No, it cannot, because B is not a descendant class of C. So you still got trouble, right? So what's going to happen? Let me write it down, and then I'll answer your question. Give me a moment. So this is really where you're going to run into class cast exception. Class cast exception. Because I'll say a little bit informally, the dynamic type of obj, which is B. Actually, let me say it formally. It's not descendants of the cast type, which is C, right? It's not. All right, yeah, any follow-up?
Yeah, so if I were to cast it, how you cast it to B to C, right? But if I were to go further, if there was another descendant class of C and I was supposed to cast it to there, would I put, instead of putting C, would I put D there?
Yeah, sure. Yeah. Okay, your question was, let's say, okay, hypothetically, let's say we got another class over here, let's call D. Let's say you want to cast from B to D. So what you're going to do is, rather than C here, you can just say D. Because you're still doing, as far as compilation is concerned, you're still doing a downward cast from A to D. So compilation-wise, you can still get around. However, when you actually get into runtime, you still got the same problem. Because can B fulfill the expectation of D? Is B a descendant of D? No, it's not. So you're still going to run into class cast exception.
Okay, so this would compile, but it would not execute.
No, to be very precise, it will compile, it will execute, but on halfway through the execution, you run into class cast exception.
Okay, but so say you ask us a question saying, "Will this execute?" Would we say?
I wouldn't. You know what? You can almost guarantee. I wouldn't ask you. When I say would it execute, it's a bit vague, right? From my the definition should be clear. Okay, so okay, just let's revisit some points maybe from earlier. Okay, so if a code can be executed, so that simply means, it's like it implies, that simply means the code actually compiles. All right, number one. Number two, if I tell you that a code runs into, let's say, class cast exception, but the same reasoning can be applied. Let's say talk about null pointer exception or array index out of bound exception. Let's say class cast exception, for example. If I tell you this, right? Basically, I'm telling you that the code can be executed. Otherwise, you wouldn't run into any exception. The very definition for any exception to occur is at least your code can be exhibited at the runtime, can be executed. And that one simply means the code actually compiles. Yeah, so that's kind of the definition, right, about execution. So I wouldn't really ask you whether the code will actually execute. Most likely, I will ask you whether the code will compiles, and if it, and whether or not you'll run into some exception. That's the way I'll phrase it.
Okay.
Okay.
Yep. Thank you.
Good. Let me just point out one more exercise. Like a reference, since you asked me this question here. The example that I was talking about. If you go back to actually the same, still week number 8. Okay. I think. Let me see where it is. Give me a moment. It should be week number 8. And I think the exercise should be maybe J6. But let me point to you where the exercise is. Okay. Maybe around the end. Just about whether you can how you can cast from sibling to sibling. Okay. This exercise over here. Right? This one here. Over there, we are actually trying to cast from C to D, something like that. But you can do it, but it's gonna run into class cast exception. So you guys may want to review this exercise over here. I even talk about how we can get around with the compiler, right? In general. Okay. Okay. Any more questions?
Sir, I have a question about the written test.
Yeah.
Would it have 7 questions like the practice test, or should we expect more?
You know what? I shouldn't really tell you exactly how many questions are there. If you
cannot, that's fine, sir.
But I would say you definitely got something similar to what you were given in the written in the example question. You definitely can expect that. So that's why I said you definitely want to grab a piece of paper and ready to sketch when you're ready.
Okay.
Yeah.
And also, should we expect the diagrams to be different for each question, or?
Okay, so I can tell you that. So the best way to do is like this. For your every time if you see a diagram over here, the first time you see that, right, draw something on your paper right away, with the annotation like what I did. Next time, if you see something similar to that, if the question itself tells you it's exactly the same as before, in that case, you don't need to do anything. If the question says maybe the question was randomized, so you might run into something that's different or the same. You may just want to check the declaration on your existing diagram quickly, just to make sure if they are the same. If they are, you can just go ahead and ask the question. You don't need to redraw.
Okay, sir.
Thanks. Yeah, okay, good. And guys, let me give you one more tip, right? You want to make sure you really review, like what I did today, right? About typecast, about many things about typecast that we spoke about today, right? And also, don't forget abstract classes and interfaces are also in the coverage, right? And the design principle we spoke about single choice principle, and also cohesion, right? So you can see throughout the inheritance lecture, even when we talk about abstract classes, and also when we spoke about the general book in your generics in Java lecture. So we also try to draw some connection to the design principle. Make sure you understood them as well. So the written test, I may not be able to cover really everything that we spoke about in the lecture, but that's something you can expect, maybe more in the exam. The exam is going to be longer and it will be comprehensive, right? But I'll speak about the exam later. For now, just worry about your written test. John.
Yeah, sorry, just a quick question about just interfaces in general.
Yeah.
So I saw in the example we did in the lecture was the point class, and we had the Cartesian and the polar. But in the point class, we didn't put any like arguments. we push that down to like only have it in the Cartesian and polar. Is that just like general how to do it? Like that's the style we should follow for like ours?
There's one thing I want to correct you. Just one thing. Okay. Let's talk about the example we. Let me give you one more example. Okay. So let's say this. So for interfaces, the only constraint is for the interface itself. Every method must be like abstract, meaning that they don't have any implementation body. But the method itself does not need to be parameterless, right? For the get x and get y, they just happen that they have no arguments, but it's not necessary. Okay. So for example, it could be that, let's say I got an interface over here called utility. Okay. And then let me say I got some method over here. Let's say integer multiply. Okay, and then I'm going to multiply, let's say, 2 integers. Not the best example, but you will see the point. Okay, so here we simply do the declaration, right? No implementation body. Okay, that's the interface. And we can have alternative implementation. Let's say suggest 2. Okay, so one would be maybe utility 1. Another one over here is going to be utility 2. Okay, and in this case over here, it could be that maybe, so here we're trying to redeclare the method integer multiply, and then integer x, integer y, right? So let's say we are trying to use a loop, right? We can say for integer I is less than x I plus plus, right? And then we have some sum plus equal y. You're trying to add up y for x many times, right? And let's say for u2 over here, you can do something very similar. Okay. Yeah, I'm just trying to show you the idea about how you can syntactically. Let's say over here, let's say for u2, let me just put it here with a different color. Purple. Okay, so now in this case, it could be they're trying to implement that a little bit differently. So here, this can be y and this can be x. Again, not the best example for in practice, but at least you will see the idea. The idea would be you got the unimplemented or deferred implementation. You got methods whose implementation is deferred in the interface, and then any class that's going to implement this interface must implement every method that's abstract in the interface. So in this case, there's one way to implement it. This is just another way to implement it.
So
make sense?
Yep. In terms of class attributes, do we only have
you know what? Actually, for interface, if you talk about subclasses over here, right, you can definitely declare a private attribute as you wish. Like in the case of a Cartesian point versus polar point, we definitely got different private attributes. In fact, in the interface, you can also put, not really attributes, we can put so-called static variable. But that's not something I will cover in this course. So I would say if you're interested, you can definitely look into to see how you can declare like a static variables for interfaces. But that's not going to cover in this course.
Okay, I understand. Thank you.
Awesome. All right, we got 10 minutes left, but any more questions, right? Hopefully that helps. All right. Okay, I'll pause for maybe a few more, one more moments to see if we got any further questions. And please don't forget, it's 2 p.m. tomorrow for the deadline to take the test, right? Don't forget. All right, guys, thank you for coming. And I hope this helps. Good luck. And if you got any other question, I still got my office hour briefly today between 3 and 4. All right. I'll end the meeting now, and then you guys take care. Good luck.